Alright folks, thanks for coming. Today we're going to continue where we stopped. Today we're on part 2 of real world applications of linear equations in two variables. Alright, this is part 2 of real world applications of linear equations in two variables, okay? Before I continue, please subscribe to my channel, like and share this video. If you have any comment, leave it under the video. If you have any question, leave it under there. I will get to it. Like I said, we will continue, man. I think I might have one more part. I might have part 3 and then I'm done. I'll move on to something else. I think after this we're going to go to exponents and polynomials. Okay, so don't forget this is just a part. Linear equations is a part of the, just a part of the algebra 1, okay? So when we're done with this, we'll move on. I'm probably gonna be done today, depending what I have going on. I may be done with all these applications today. That way tomorrow we can move on to exponents and polynomials. All right, so thanks for coming. Let's do some examples. All right, here is our first example here. It says, what is the slope of the slide? It says, a hint. The slide drops 8 feet vertically as it extends 12 feet horizontally. So basically, you see the slide, I think this is a slide for kids. They get up there, then they slide down. It says it drops 8 feet vertically and then it descends 12 feet horizontally. You see that that 8 feet is negative sign because it drops. It drops from, if you get to physics, you see a lot of that, depending on where where they put the zero. Because you see, always use Cartesian coordinate, right? Depending on where they put the zero, it looks like if you look at that diagram, it looks like they have, they just put, that's what I think they did. They went like that, they put 0 here. And that's why, okay, coming down here is negative y, okay, negative y. And this is x, this is negative x, okay? So you see this a lot if you do physics, so because it's dropping, they assume that it starts from 0 and then drops. That's why it's negative sign. Anyway, let's solve it. They say, what is the slope of the slide? Let's solve this. It's not that difficult. What is slope? You remember? We did a lot of this. Slope is equals to, remember, change in y over change in x, okay? The same thing as rise over run. You remember that? Rise is going up like that. That's it's a y-axis. Run is going up like that. That's the x-axis, okay? X, run, y, rise, okay? Alright, so you see the rise there is minus 8 feet. The run is 12 feet. That's all they're asking, man. Put that in the equation and then solve, okay? You put that in there, sorry. You put that in there, what do you get? You put that in there, minus 8 feet over 12 feet, okay? What do you get? You get, you're gonna get minus 2 over 3. So that's the slope right there, negative 2 over 3. See the clue you have there, see that hint, it drops. It drops 8 feet vertically. When something drops, it's going down, negative direction. But if you shoot something, it goes up, then it's going positive direction, okay? So basically, that's all they're looking for there. That one is not a rocket science. We're done with it. Okay, here is example 2. It says, what is the slope or grade of this scale it was a ski slope. And then it says, hint, the ski slope drops 25 feet vertically for every 100 horizontal feet. Again, the same concept. Okay? The same concept applies here as I discussed before. There is the zero is here, okay? The y-axis here, x, negative x, positive y, negative y. And this zero right here, so it drops. Okay? And then it extends 100 feet to the x-axis also. So they want you to find the slope. Okay, so we'll do the same thing we did before. Slope is equals to rise over run, right? Okay, rise. All right, always remember rise is vertical. Okay, so rise over run, that means negative 25 is rise, and then 100, positive 100 is the run. Okay, so that you work that out, it will give you negative 1 over 4. And then we're done with that one. That one is finito. Okay, look at the next problem. It says this graph shows global shipments of desktop PCs and tablets in millions of units from 2010 through 2016. Use the graph to work each problem, okay? Locate the line on the graph that represents tablets. Alright? I have another problem that the next one is like this. Locate the line on the graph that represents tablets. That's it. Tablets is the yellow. I'm sorry, the blue line. The blue line is tablets, okay? Then it say write two ordered pairs. X, Y, where X is the year and Y is shipments in millions of units to represent the data for the years 2010 and 2016. Write two ordered pairs. Alright, let's see if we understand what they're saying. Okay, I think I know what they're saying. They're saying write two ordered pairs. Of course, you know that you have, let me see, you got 2010 right here, and then you got, what is that, 2016 right here. Okay, so they even give you the number. So the two other pair, there are a bunch of them. Two other pair, let me see. Okay, they're talking about the tablets, right? That's the tablets. I'm trying to understand what they want. Okay, sorry, not that one. They're talking about, see, we gotta read, see, they want to deal with tablets. Okay, so they're dealing with this line. You gotta stay with that line right there, the blue line. So two other pairs. Okay, year represent X axis. So you gotta write X axis first. Say 2010, and the Y there, they give it to you 19. You write it there, and then another other pair 2016. That's the X value. Then what does it correspond to tablet right here? 175. Okay. So you gotta be careful. You don't want to make, because there's another problem that deals with that. That we use the red line. That's our next problem. I cannot split the problem into two. It was originally one problem, but I don't know how to put it in distance, so I cannot split it into two. Let me see. What is the next one? B. Use the other pairs from part A to find the slope of the line. You see that? Well, you remember the slope, right? We just say B. Slope is slope is M equals to what? Rise over run, right? or if you don't have, if you have 2 points, you remember, if you have 2 points, let's use this one as, let's use as remember what we did, we use that as final point, we use that as initial point, okay, and then we remember it's change in y, okay, over change in x, okay. So you always gotta keep that in mind. What is y and x? X is the years, right? So we'll say 175 minus 19 is over 2016 minus 2010. You see that, right? So you gotta be consistent. If you use this as the final point, you gotta be consistent. Okay? Okay, so when we do that, we'll simplify what we'll get. So I hope you understand what we did. We learned that we did a lot of this in the past, you remember? So you should be able to recall what we just covered in maybe 4 or 5 days ago. So you should be able to recall that, So here is this, it's a 156 over, let me see, 2016, right? 2016 subtract 20, I think it's about 5, 2010. All right, yeah, 6, it's 6. Okay. So 156 divided by 6. It gives you a nice number. It's a 6. I'm sorry, it's 26. Okay. Now, that's the slope. Okay. Now, what does it say? Interpret the meaning of the slope in the context of this problem. Okay. See, you find the slope, but what does slope mean? What does it mean? Remember, we started with tablets. We're dealing with tablets now, not with PC. We're going to get to PC in the next problem. So here, the slope means, it means that, it means that it increased. It increased 156 million of units, right? 156 million in units in 6 years. See, this is, you can even look at the graph. See the graph and follow, there's 6 years interval there, right? There's 6 years interval there. Alright, so it increased. It went from 19 to, let me see, it went from 19 to 156. It increased in 6 years, because that's a period of 6 years, okay? That's what that slope is saying, So, but then the number means every year there are 26 million units that increase per year. So basically they ship 27 million units per year. That's what that is saying. Because don't forget, man, this is, see the way you look at it, this is, over here, this is year, and this is units, okay? Units over here. So, over time, right, increase 156 minutes in 6 years, and then they shipped 26 million units per year. That's all that is saying, man. But anyway, let's see. That's C. Okay. We just answer C. That means there. Let me write it there. That we're increased shipments. shipments of tablets, okay? Shipments of tablets, the increment is like 156. It increased 156 million, okay? 156 million units in 6 years, okay? 6 years. That's what that means. So you actually gotta read up from here. It increased 115 million units in 6 years, and then the actual number there, it means they sold because it's like average. On average, they sold 26 million tablets. Million tablets, okay? Every year, okay? Every year, between 2010 and 2016. That's all that is saying, man. Make sure you understand that, you see. So, but anyway, we're done with this thing, man. So we're gonna move on. Just leave it alone. Here is example number 5. It says that it's similar to the other one. About 4-year colleges. Freshmen and 4-year colleges that want to major in something. This one, they want to major in business. What is that? Business. They plan to major in businesses. Okay, business. All right. They say find the slope of the line in figure B to the nearest 100. See, the same thing we did before. And then it says based on the slope, is it increasing and decreasing? That's B right there. And then it's C based on figure, what was the decrease in the... Okay, so I think if you look at the slope of the one, you see the slope is increasing. It's a positive slope. Notice that based on what we know about slope, we studied this in detail. Remember, this is a negative slope and it's gonna be decreasing. So let's work it out. I want you to keep that in mind. It's a decreasing slope. Okay, let's do what they want us to do. It says find the slope of the line. Okay, we are given a couple of points. You see the points there. We are given, let me see, we are given 2000, again these are year X, and percentage of students that major in business, Y. The year 2000, there was 16.7, okay. Alright, and then a second order pair is given right there, see they're giving right there. 2016 13.8. Okay, you see what, if you look at it carefully, try to understand the graph. It starts here and then it goes down that way. So I like to say this one is this one is initial. It helps me not to make mistake. This one is fine because it is a change. Something happened. It changed from something to something else. Okay, that's how you conceptualize it. Okay, slope. What is slope? Slope has to do with change. Okay, change in y over change in x. Okay, so what is that change? Change in y is, don't forget this is y, this is x. Change in y is 13 point, use the final one, subtract the initial one, 16.7, okay? The same thing with change in x, 2016 minus 2000, okay? The year 2000, that's all. You do that, what do you get? Let's do that. Then what do okay, so we get minus 2.9 over 16, and then if we're gonna end up with the decimal, it's negative 0.18. There are some other numbers, but we don't need that. There's like 1, 2, 5. We don't need that. So you see negative, it's a negative slope. Remember I told you. You see how it's sloping down. When you look at slope, you always gotta go from left. You go from left looking to the right. Then you see it's going down. If you had a car here, let's say you had a car here. You see, the car will be heading that way. It will be sloping down. That's all that means. Okay, so we got the slope negative. So the slope of the line is negative. Okay, slope of the line. That's what the B says. Slope is negative. Okay. So that means that the students planning to do major in business decrease. Okay. Student planning to major in business, okay, actually decreased, okay, it decreased. That's all that is saying, man. Okay, question number C. Based on what was the decrease in the percent of freshmen per year who plan to, okay, so that one is the same thing like we did before. The percent is right there. That thing is, I don't know how, well, that thing is, sorry, it's 0.18%, okay? 0.18%. Again, like I said before, is the 10%. To remove percent, you gotta say it's zero. Let me see. If you remove that percent sign, then it becomes 18 over 100. Okay. So it's the same thing as that's the same thing as 0.18%, 0.18%. Okay. Because if you divide 18 by 100, you get 0.18, okay? So that's it, just 18%. That means it decreased, okay? Because the slope was negative, remember? That thing is negative right there. So it decreased. So it decreased 18% every year. That's all that is saying. It decreased 18% every year. Every year between, you remember, 20,000 and 2016. That's all that is saying. That's all. It's not saying more than that, okay? Alright, here is our next problem. The previous problem was solved. There is a second part that deals with desktop PCs, but I think I left that out. But I went back and looked at it. It's the same thing. The same thing they said, look at the line that represent PC and do the same thing A, B, C, D. I mean, it's okay. If you can do the one for tablets, you can do the one for PC. So we'll leave it alone. We'll just move on to the next problem. Here is the next problem. Here, it says, let's read that. It says that figure A gives the percent of freshmen at four-year colleges and universities who plan to major in the biological sciences, okay? And then it says find the slope of the line in figure A to the nearest 100. Then B, the slope of the line in figure A is positive or negative. Well, positive or negative, yeah. This means that during the period represented, the percent of freshmen planning to major in biological science increase or decrease. In other words, if it's positive, then it increases. If it's negative, it is increased. The way they wrote it is confusing. And then he said the slope of a line represents the rate of change. Based on figure A, what was the increase in the percentage of freshmen per year who plan to major in biological sciences during the period? All right. Again, you see, I told you that the linear equations they are very, very important in applications. Okay, so they use it to apply, a lot of real world problems, man. To solve a lot of real world problems. So, if you understand the linear equations, one variable, two variables, you're gonna be able to deal with a lot of problems you meet anyway. I see. So, but anyway, let's kick this stuff out. Now, what they're looking for is the A. Let me see, where is A? A is right here. It says find the slope of the line in figure A to the nearest 10. Okay, so what is slope, man? We talked about this in the previous, but slope is rise over run, right? The best way to find it, we got 2 points. You see this point here and that point here, and they are given. Okay, let's see A. Look at, if you get 2 points, you can find the slope. They give you 2,000. By the way, x-axis represent year. Y-axis represent the percent. The percent of freshmen that plan to major in biology, okay? So this is, make sure you study that graph carefully. That's how they apply these things, you see. They use y-axis for something, x-axis for something, okay? So we got a couple of other pair. We'll have that 6.6, okay? 6.6, and then we'll have another one, 2016, and 15.7, okay? That's it, it's given. Alright, so with that other pair, we can find slope. You remember? Slope is equals to, what is that, change in y over change in x, okay? So we said this is the beginning, initial final. So I like to do it that way I don't get confused. Okay, so that's the beginning point. The beginning order pair, the final order pair. So it starts here and then it goes and ends here. That's how I think about it. That way you don't make mistake when you're finding the slope. So a change in y is, don't forget this is x, this is y, okay? Change in y is 15.7 minus 6.6. See, that's why I said this is final. So you start with the one where they ended, you subtract from the one where they started. It's over, let me see, 2016 minus 2000, okay? See that, right? Alright, what is that? You work that out. Alright, see that here. It's 9.1 over 16, okay? So if you work, it has to be, of course we have no choice, it has to be decimal. So this is approximately 0.57, okay? 0.57. That's what it boils down to, 0.57. If you divide that with your calculator or whatever, however you want to divide that, you're gonna get let's see, 0.5687. So you just round it up to 2 decimal places. Alright, but you see, we're working with, well, it's okay, we'll leave it there. Now let's what is the next question? The slope of the line in figure A is positive or negative. This means that during, okay, the slope is positive, it's not negative. So this means that during period, the percentage of freshmen plan to major in biology, so the percentage increase because it's positive. That's all they're saying there. This is B. Okay, the percentage of freshmen planning to major in biology. Okay, percentage of freshmen planning to major in biology, okay, increased. It increased in that period, okay, because the slope is positive. It increased. That's how you read that, man. Yeah, it increased. Then C, what is that say? C, the slope of a line represents the rate of change. Based on figure, what was the increase in the percentage of freshman per year? Who planned to measure? Well, we'll solve this problem. I don't know why they're asking that. The percentage is, well, I mean, we got it over there. It's 57%. Okay, don't forget that. Remember we talked about this 0.57, right? Can be written as 57%, okay? Because 57% means 57 over 100. And that's the same thing as 0.57, okay? So make sure you keep that in mind. Don't get confused, man. So the percentage is 57%, and that percent means they increase, approximately increase 57%. That's all, okay? So we're done with that problem, man. We're done with that one. We'll move on to something else. All right, here is the next example, number 6. It says Andrew earns 5% commission on his sales plus a base salary of $2,000 per month. This is illustrated in the graph and can be modeled by the linear equation y equals to 0.05 x, right? I'm sorry, y equals to 0.05 times x plus 2,000. Okay, where y is the monthly salary in dollars, x is his sales, also in dollars. Okay, so make sure you keep your eyes over here. Sales in dollars, x axis, and the salary in dollars, y axis, okay? Alright, so you keep your eyes there. Let me make it a little lighter, that way you can see a little more. Okay. Alright, so you see that, right? You see that. So what they want is, you are given linear. So what is the slope? What does that slope correspond in the problem? Okay, so you're given an equation. They want you to find the slope. Don't forget we spent a lot of time on that. The equation is 0.05 x plus 2,000, okay? Okay, so this slope, compare it to the what they call slope-intercept form. Slope-intercept form is, let me see, it's y is equals to mx plus b, where the b is y-intercept, m slope. You compare it with that, right? Then you can see that the slope m is equals to 0.05. You see that, right? If you compare those, see, look at that and look at that. Okay, and then look at that and look at that. If that helps you, you see that, right? So that's how you compare that. You say, what does the slope correspond in the problem? Well, the slope corresponds to the commission. You remember? It says that you gotta read the price. Say Andrew commission say plus. This is also by okay. The slope corresponds to the commission. The 5% is the commission. Yes. Yeah. Okay. Slope is the slope is the commission. Okay. Commission he earns. Andrew earns. Okay, slope corresponds to the, well, you can call it the commission rate, because slope is a rate, okay? Alright. And then you see, what is the y-intercept? With what does the value of the y-intercept correspond in the problem? Okay, here is B. Y-intercept, see, we'll compare it right here. Y-intercept is, y-intercept is 2,000, okay? Right? Y-intercept is 2,000. And then he said, what does he say? Well, what does the y-intercept of the y value of the y-intercept correspond in the problem? Well, it corresponds to it corresponds to, I think, let me see. Y-intercept, if you look at the graph, where does it, see right here. Don't forget now, what is y-intercept? Y-intercept is where x equals to 0. Right? Where x is equals to 0, right? So where y-intercept is where x equals to 0. So x is 0 right here, and then what? See, that's the base salary. Can you see that? That's the base salary right there. Right there. That's what the problem says. The base salary per month. Okay, so it corresponds to the base salary. Then what is it say? See, use the equation to determine Andrew's monthly salary if his salary if he says 10,000. Confirm this using the graph. Okay, so basically we use the equation and then we use the graph to see if we get the same thing. That's what they're saying there. Okay, so see, they said that if he sells at 10,000, so remember y represents let me see, sales of x represents sales. Okay, so x represents sales, and then say use that to determine Andrew's monthly salary. Y represents salary. Okay, I know what they're saying. This is the equation here. Okay, 0.05x plus 2,000. Okay, so they're basically saying that C, the number C, is saying that if his salary is 10,000, which is y axis, so it basically saying if y is equals to 10,000, salary is 10,000, and then what is x? Okay, that's what they're saying there. Use the equation to determine the monthly salary, right? Hang on a minute. Yeah, I switched it around. If sales is that, I'm sorry, salary is y. Sorry, salary is y. Hang on, sales is. I'm sorry, I switched it around. Sorry, this is actually, I switched it around. This is x is equals to sales is equals to 10,000. Then they want to know the salary, right? Let me see. Yeah, monthly salary. If they say okay, they want to know the salary. The salary is y. So what you do is say y is equals to 0.05x, which is that value given to you. That value they gave you, 10,000. Okay, 10,000 plus 2,000. Okay, what is that? Man, we're running out of space, man. Alright, so this is what I did the calculation. This is what you get. You get 2,500 for the salary. Okay, that's what I calculated there. Alright, so what is D? We run out of space, man. I'm gonna make space. Let me make space. Let's make space. We're gonna make space. So M is the commission rate. See, I wrote it wrong. That's commission. Why did I write that wrong? Just give me a minute. Let me figure out what I'm doing. It's up here. Commission is the commission rate. Okay, that's M. I want to make space. M is the commission rate. Okay, because I don't have any more space. We're gonna do D here. Oh, we haven't finished C. C says, what is C say? Use the equation to determine the monthly salary. If it's confirm this using the graph. Okay, let's use the graph. We got monthly salary of 2,500, and that says 10,000. Let's use the graph and confirm this. Sales are here, 10,000 right here, and then if you go up, that's what they're saying, go up. Or there are two ways you can do it. You can do it with graph, or you can do it with algebra. See right there, right? So it will confirm that it's 2,500. Now, what is D saying? Use the graph to determine his sell if he wants to a monthly salary of 35. Again, it's easy. So this is D. We're gonna use the graph to confirm his sales if his monthly salary is 3,500. The salary is over here. 30. See, that's 3,500 here. Let me use red pen. 35 right here. You go to the graph. You cross right here, and you go down. So the sale is 30,000. The sale has to be $30,000. So you see that, right? That's how you do that. 30,000 in sales. In sales, okay. So that's what that is saying, man. That's what that is saying. I mean, you can also solve that using the equation. You can say, but you see, they say use the graph to determine, so we use the graph. Oh, you say confirm it. Confirm this using the equation. Okay, fine. And then we'll do y is equals to 0.05x plus 2,000, okay? Now I'm going to write small. You say confirm it. So don't forget they gave you monthly salary of that, okay? Which means you put that. Let me see, that's y. You say 3500 is equals to 0.05x plus 2,000. You solve for x, that's all. Okay, that's all that is saying. You solve for x, so you got 3500 minus, you bring 2,000 over here, it's equals to 0.05x. You see that, right? So that's 2,000 subtracted from 3,500, you get, what is that? You get 1,500, okay? If you take out 2,000 from there, okay? So that's 0.05x. And then you say x is equals to 1,500 over 0.0. That's all. If you do that, use your calculator, do whatever you want to do it. If you allow calculator, use calculator. If you do that, what do you get? Divided by 0.05. See, you get 30,000. That's the same thing we got before. So we'll solve the problem, man. So we are done with that one. Okay, here is the next one. It says the cost to rent a moving van is $0.50 per mile plus a flat fee of $100. This is illustrated in the graph and can be modeled by the linear equation, right? Y equals to 0.50x plus 100. And then they say where x is the total rental cost in dollars and x is the number of miles driven. So basically what this problem said, you rent a truck, you gotta pay a flat fee of 100, and then they will charge you 15 miles per hour, okay? I'm sorry, 15 miles per mile, okay? So you move from that lot and start driving 15 miles per mile in addition to $100. That's all that problem is saying, man. So I mean, all of us have rented car like that in the past. I think they don't do it like that anymore. But anyway, so notice that can be modeled with a linear equation in two variables, okay? Miles is x-axis, and the charge, the cost is y-axis. You see that, right? The cost is y-axis right there. Okay, sorry about that. That was the airplane passing by. Listen, the question A says, what is the slope? With what does the slope correspond in the problem? Okay, now you remember, you gotta compare that to, because it's already in the form of slope intercept form. If you remember that formula, it's like y is equals to slope times x plus 100. I mean, I'm sorry, plus b, where b is the slope intercept form. See, you compare that, you see that, see x there, you see that. So slope is the slope is actually 0.50, okay? If you compare that carefully. Okay, so we gotta be careful because I gotta conserve space. That thing is long. I don't want to run out of space. So what you say? What does the slope correspond in the problem? In other words, when they talk like that, they just want you to interpret the slope. What does the slope mean? You understand? So you always gotta keep that in mind. The slope means something. Slope has a meaning in the context of the problem. You see? So slope means, as far as I can tell, slope here means it's cost per mile of renting the van, okay? Slope is cost per mile. Because don't forget, always remember how they define slope. For you to remember that slope is equals to rise over run, okay? So it's I'm gonna stop this. Plane is coming again. Okay, don't forget that. How do you define slope? It's rise over run. In this problem, see, rise is that, run is that. So it's cost per mile. That's what that slope is. It's cost per mile. Okay, that's how you say it. I mean, you can say here, slope is cost per mile. See, cost over miles. All right. So B says, what is the y-intercept? The y-intercept is compiled with the problem is b equals to 100. Y-intercept is 100, and then they say with what does y-intercept of the y value of the y-intercept correspond to the problem? It corresponds right here. They gave it to you right here. It corresponds to the flat rate. Okay, you see it there, right? The flat rate. So it corresponds to the flat rate. Okay, let me write it here. I want to. That's the flat rate. Okay, I want to make sure I have enough space to finish all the problems. Okay, so see what is it? Use the equation to determine the total charge if 400 miles are driven. Confirm this using the graph. Okay, see what C is saying is if X is equals to 400, determine Y. Y is the total charge, so Y is equals to 0.50 X plus 100. If you put X equals to 100, you get 0.50 times 100, okay? I mean, so times 400 plus 100, okay? See right there, right? That's the same thing as multiply 400 with what is that, 0.5 times 400, okay? You get 200. So that's 200 plus 100. That's what, 300, okay? You see that, right? Okay, so you see that? That's what that means. So I think they want you to confirm that using the what is it? What they say? First, you use the equation and confirm that using the graph. Okay, so what are we looking for? X equals to 400 is right here. X equals to 400. Let me get a red pen right there. You go up to the graph. Where does it intersect with the graph? And then you go to the y-axis, which represents charge. That's 300 right there. You see right there. Okay, so we'll confirm that using the graph, okay? So it's confirmed, okay? And the D, use the graph to determine the number of miles driven if the charge is 500. Confirm with the equation. You basically going back and forth to use graph, then you use the equation. Let's use graph if the charge is 500. Okay, charge, in other words, y 500, okay? That's all they're saying because y is charge. If y is 500 in the graph, what is that right there? It's right there, okay? Then you go to the graph, see where it intersects, the graph crosses the graph, and then you go down. See, it's 800. You see that, right? Okay, from graph we will get 800, okay? Now can we do it? They say do it, confirm using equation. Okay, fine, we'll confirm it. Yeah, we can confirm that. Okay, we can confirm that. Let's see, just plug that in the equation and solve for x. Y equals to 0.50x plus 100, okay? You plug y equals to 500, that's 500 is equals to 0.5 50x plus 100, okay? So you solve that, what do you get? You get 500 minus 100. I moved the 100 to the left, I moved it over here, and it changes sign. That's equals to 0.50x. Okay, so you do that, what do you get? You get 400 is equals to 0.50x, okay? And then you divide by, it's 400 divided by 0.50 is equals to x. What is that? You do that, I bet you it's, I'm hurrying up, I bet you that thing is 800. 400 divided by 0.5, yeah, it's 800. So that's 800, and we're done. We'll confirm it, and we're done with that problem. Okay, let's move on. We'll move on to something else. All right, here is example number 8. I'm gonna read it for you. It says the cost Y of producing X items is, in some cases, expressed in the form Y equals to mx plus b. The value of b gives the fixed cost. The cost that is in the same. The cost that is the same no matter how many items are produced. And the value of m is the variable cost, the cost of producing an additional item. Use this information to work each problem. Okay, they give A, B, C, D, okay? You say it costs $400 to start a business selling campaign buttons. Each button costs 25 cents to make. What is the fixed cost? B. What is the variable cost? C. Write the cost equation. D. Find the cost of producing 100 buttons. How many campaign buttons will be produced if the total cost is $775? You see what I told you? Linear equations, man. 2 variable, 1 variable. They're very, very good. They are very, very good in use to model real life situations. Right? See that problem described there? This is for real. You know, see if there's something, well, they talk about fixed cost and variable cost. Let's say you're starting a business, you have to rent a building, right? And then you rent that building, you know, they charge you, let's say, $3,000 a month for the building, right? That's a fixed cost. You gotta pay that every month. All right? And then what of electricity you're gonna use? You're gonna use electricity, you have to use water, you have to use the internet. So depending on what you're doing, what you're producing in that, it's a factory, what you're producing in that factory, the amount of electricity you use varies every month, right? So those are variable costs. That's the cost of producing the value of, they say, you know, the variable cost, it changes depending on how the amount of material you use to produce whatever you're producing, right? If you use a lot of electricity, you pay more. If you use less, you pay less. This I'm just using electricity as an example. There can be other stuff like raw materials. If you're producing 200 today, you use a raw material that will be enough. But supposing tomorrow the demand is high, you're producing 2,000 units, okay? Then the cost of material will go up. That's variable cost right there. So, you see, this is very, very interesting. They're telling you the variable cost can be modeled by the slope, and the fixed cost can be modeled by the B-intercept. Very, very interesting. You know, so, but anyway, let's deal with this problem as given. Okay, so what is the fixed cost? Okay. Now, you're given this part here. It costs $400 to start a business selling campaign button. Each button costs 25 cents to produce. So let's do it carefully. We'll conserve space because we don't really have a lot of space. What is the fixed cost? In this situation, you see, they gave you this slope intercept form. Remember, they give you that mx plus b, and they're telling you that over here they said that you gotta see what they're saying. They say y producing x items. Okay, the cost of y producing x items is expressed here, and then they tell you b is the fixed cost. Right, m is the variable cost. You see that, right? Make sure you keep that. Yeah, you gotta keep that in mind, man. Okay, so based on what they're telling us, then the equation becomes. Let me see. I don't want to take too much. The equation becomes the 400 is the fixed cost, right? It will be the equation then becomes it becomes, what is that? Hang on a minute. It becomes 0.25. You don't even have to write the equation to answer that question, and then 400. Okay, so but 400 is the fixed cost. Okay, because 400 is the fixed cost right there. M is the variable cost, that's the slope. B is the fixed cost because B is constant. It crosses y-axis, y-intercept, okay? Alright, so what is the variable cost? Okay, that's B. The variable cost is based on what they give us there, right? The variable cost is okay. The variable cost is 25 cents. 25 cents is the variable cost, you see? Because if you look over here, okay, that's the variable cost, because you see, they said it here. Look over here, right here, the variable cost is right there. That's the slope. So the slope is 25, okay? Because if the thing changes, then you multiply by 0.25, okay? So make sure you understand that, man. And then write the cost equation. Okay, so the cost equation, what they mean by that, remember that the cost is y. The cost y of producing x items. So the cost equation is y is equals to, we'll put the values we already found in b and a. I think I wrote it already. It's 0.025x plus 400. That's the cost equation, right? Because y is the cost, right? So yeah, that's the cost equation there. So let's do D. It said define the cost of producing 100 buttons. So what represent the items is x. X represent the item right here. X did the items, okay? So it's saying that if x is equals to 100, what is the cost? Of course, is the y. If x is 100, then y is equals to 0.25 times 100, okay? Plus 400. So you simplify that. What is 25? What is 0.25 times 100? I think it's only 25 bucks. It's 25 plus 400, okay? So that will give you 425, okay? That's the cost. This is dollar. That's the cost of producing that. Okay, you see that, right? What else did it say? Find the cost of, okay. That's the cost of producing 100 buttons. Okay? And then what is that C? Did I jump? No. The E. Number E. How many campaign buttons will be produced if the total cost is 771? Again, you gotta stay focused. They're asking you if Y is equals to that. They're giving you the total cost and say how many buttons can you produce? How many items can you produce? Then you say you put that value of y in the equation, right? This is the equation here. Then we get 400. I'm sorry, not 400. 7. Then we say 775 is equals to 0.25x plus 400. And when we solve for x, that's all they're asking there. Okay, you move things around. 775 minus 400. You see that? is equals to 0.25x. You see it, right? Okay. So you do that, what do you get? 375 is equals to 0.25x, okay? You see it, right? Then x is equals to 375 divided by 0.25. And then what do you get there? Once you've done that, we're done with the damn problem. 375 divided by 0.25, you get 1,500 items. That's what you produce. If they give you the cost is 775. And guess what? We are done with that one. Okay, so we'll move on. Okay, look at this one. Example number 9. It says it costs 2,000 to purchase a copier, and each copy costs 0.02 to make. So each copy from the copier costs 0.02 to make. And they say, A, what is the fixed cost? B, what is the variable cost? C, write the cost equation. D, find the cost of producing 100 copies. E, how many copies will we produce if the total cost is 2,600. Like I said, if you look at this carefully, think about it carefully. These linear equations in two variables or one variable, they're very good in modeling real world problems, okay? This is not a joke. This is real. Imagine you're starting a business. You want to open Kinko's in India or Kinko's in Africa, right? This can be useful to you. You want to know how much you're going to sell it. How much does it cost you to buy the copier? How much can you make if you do this and do that? You see, all that stuff can be answered using, a model of linear equations in two variables, okay? That's what that is telling you there. Now, the first question is, what is fixed cost? Second question, what is variable cost? Remember what we did a few minutes ago, right? That problem is really good. You gotta read that problem again. See, this information is giving you here. That thing is very, very useful. It tells you that this slope-intercept form can be used to model fixed cost and variable cost, right? Where y is the cost of producing X items, right? And they're telling you that B is the fixed cost because B is a constant, right? M is variable cost because M is multiplied by X and X changes. You understand that, right? Keep that in mind. That's very, very important. See, when you solve some of this problem, you also learn from it. So what we know is that y, the slope-intercept form, written like this, mx plus b. B is the y-intercept when x is 0. From the previous problem, they're telling us y is the total cost, okay? Y total cost, M is the variable cost, okay, and then B is the fixed cost. Fixed cost, I didn't put that there. Fixed cost, variable cost. You see, look at that. Total cost, variable cost, fixed cost. All that can be gotten from that equation, man. So we applied that here. What do we got? And don't forget the equation also. In the equation it say X items, will be produced, okay? Whatever, even if it means services, X services, if you're providing services like Kinko's, so let's solve the problem. A, what is the fixed cost? Well, based on, see, what you do here, you are given the cost. It costs 2,000 to purchase a copier. Then say each copy, to make each copy will cost 0.02 $0.02, right? Okay, so you have to use those two constants. You use that and use that, all right, to put it in this equation here. That's all they're asking you to do in A. You see what I'm saying? So you have to make sure you understand that. Alright, so what is it asking you? I'm sorry, the A is, what is the fixed cost? Well, like I said, we don't have to do the equation, but if we do the equation, it's helpful to visualize it. So we can have y is equals to, what is that? It costs that, okay, that's fixed cost there. So we can write it like this: 0.02x plus 2000. You don't have to, but it helps you to visualize it. Then you can answer A. The fixed cost is 2000, okay? You know, I mean, you could have answered it without the equation, but if you put the equation there, it helps you to visualize it, and it will help you to answer other questions coming. Then you say B. What is that? What is the variable cost? The variable cost we know is right there. It's 0.02. Right? That's the variable cost based on what we learned from the previous problem, okay? And based on what we define here. And then it says write the cost equation. We already did that. The cost equation is y equals to 0.02x plus 2000. Basically, we'll model that. We'll model that equation right there. We'll use it to solve this particular problem. That's all. You know, so, and then what is the next thing? What is D? D says find the cost of producing 100 copies. Now, you gotta separate the items and the cost. Y is the cost, right? X is the item. So what they're saying is, suppose you have X equals to 10,000. Then what is the Y, which is the cost? Y is equals to 0.02x plus 2000, okay? Which is the same thing, and you multiply. You put that value of Y in there, X. Put that value of X in there, and then you get 10,000 plus 2,000, okay? And then keep going. What is that then? You multiply that. We multiply that any way is convenient for you. They give you a calculator, use it. They don't give you a calculator, they use long, remember the multiplication. There are tricks to multiply that without even needing a calculator. Because you put the decimal in form of fraction, and then everything will cancel out. You see, so that's okay. 0.2 times 10,000. I'm sorry, 0.02 times 10,000. That's 200. I will show you in a minute what I mean, what I just said. Just give me a minute. So you do that. What do you get? You get 2,200. Okay, that's what you get there. 2,200. All right. Okay. So now, supposing you are not allowed to use calculator, right? Supposing you are not allowed to use calculator, see 0.02, you see the same thing as you know what? Let me leave it alone. I don't want to confuse you. Let's keep solving the problem. Don't worry about that. Let's keep solving the problem, because I'm gonna run into all kinds of stuff. So what is this here? What is it actually? E. Did we finish? Did you find the cost of? Okay, we did. This is the cost right here in dollars. Okay. All right. How many copies will be produced if the total cost? Okay. Now they give you Y is equals to 2,600. Okay. And I want you to see how many things you can produce using that amount. They want you to find X. Basically, you put that into that equation here. Okay. The equation is 0.02x plus 2,000, okay? And you put value of Y, 2,600, is equals to 0.02x plus 2,000, okay? You solve for X. You move this to the left. It changes sign. It's 2600 minus 2,000, okay? Is equals to 0.02x. All right, see that, right? And you simplify that, you get one. Let me see. No, you get 600. Okay, 600 is equals to 0.02x, and you say x is equals to what? 600 divided by 0.02. What does that give you? You see what I'm doing, right? It's very simple, man. That will give you 30,000. Okay, that's what you're gonna produce, given that amount of money, and giving you your setup. This is your setup right there. So you produce that amount, this amount of units, given that amount of dollars here. All right. You see what we did, right? So you're gonna produce 30,000 copies, okay? If you have 2,600. This is real though. This is real, something like Kinko's can be opened somewhere, but you modify it a little bit. This is what the problem we just solve will tell you. If you have this is what you will produce. This is how much you make. This is your variable cost. This is your fixed cost. Stuff like that. This is your total cost. But anyway, I'm done with this one. So let's move on to the next one. All right, folks. Our next problem is very long. You remember when we started, I told you that this is that thing you're looking at about there, the standard form of the linear equations in two variables. See x here, right? See y here, okay? And then c is constant. I told you that. That's the general, what I call the standard form of linear equations in two variables, okay? We're gonna work with that now. One problem that we're gonna work next, use that idea. So make sure you keep that in mind. The one here is linear equations in three variables: x, y, and z. Okay, but we're not gonna deal with that here. I just put it there that way you know that such a thing exists. So let's look at the next problem. That way you see why I have to show you this beginning images. You see why I have to show you the beginning images right there? Okay, this is the problem. It says it's a long problem. So what I did is I'm gonna divide the rest of the page into two. Okay, that way I can squeeze all the solve 1, 2, 3, 4 problems in there. Okay, now I'm gonna try to do 2 problems on the left and 2 on the right if I can. Okay, let's read this. It says a line with equation written in the slope-intercept form, y equals to mx plus b, has slope m and y-intercept 0b. The standard form of a linear equation in two variables is ax plus by equals to c. Remember, I showed you that at the beginning. Alright? This is the standard form, where a, b, c are real numbers, and a and b are not both 0. Okay, remember we talked about that somewhere. Anyway, so they give you this problem right here. It says write the standard form of a linear equation in slope-intercept form. That is, solve for y to show that in general the slope is given by minus a over b, where b is not equal to 0. You see, this stuff is not actually very clear. They're talking about in two variables though, and they didn't mention that, but it's well, it's understood because I guess it's implied, because the standard form is usually two variables. Okay, so what they're asking in number 1, solve that, express that in the slope-intercept form, express this in that form. That's all they're asking in number 1. Do you see that, right? Make sure you read that, understand that, and then I can do it here. That's number 1. You are given ax plus by equals to c. This is how they express it. Sometimes you can put c on the left, but that's how they wrote it, so we use that. Okay, I want you to write it in slope-intercept form. Write it in slope intercept form. That is solve for y to show that, okay, we can do it. Okay, let's solve for y. So to solve for y, remember what we've been doing. There's no magic here. This is the same thing we've been doing from the beginning. So you move things around. Just move things around, man. You isolate whatever, you isolate y. So let's leave you, by is equals to c minus ax. I just moved the ax to the other side and change. This will show you, it will show you all my skills, the way I do stuff. It will be clear in this problem, okay? Just keep paying attention. By is equals to c minus ax. I moved ax to the other side and the sign changed, okay? Alright. So we're solving for what? We're solving for y. We're going to solve for y this time. How do you solve for y? You divide everything by b to so that you can leave y by itself. So y becomes equals to c over b. You see that, right? Because I divide everything by b. Minus a over b, and then you still have x there. You see that, right? So there's no magic there. So we can rearrange it to look like this one here. What is that thing? Look like that one there. So let's rearrange it. We'll have y is equals to minus a over b x plus c over b. You see that, right? We didn't do anything. We just rearranged stuff to put it in that form. To put it, let me write that down here. To put it in this form, y is equals to mx plus b. We just want to put it, that's what they want us to put it in that form. It's in that form now. If you compare those two, compare them, what do you see? You see m is equals to minus a over b. Right? You see it, right? And then you see, this is called the y-intercept. The y-intercept is c over b. You see it? Okay? There's no, we didn't play any trick. We just solved it, and then remember over here is b cannot be equals to 0. B cannot be 0. That's what they said. Where did they say that? Right there. B cannot be. Because if B is 0, then that thing is undefined. Okay? So we got that. That's what they want in number 1. Okay, so use the fact that m is, see? That's what we got. M equals to minus a over b to find the slope of the line with each equal. Okay, they gave you a bunch of the equation and tell you to find use the fact to find the slope of the line with each equation. That's all they're saying. So let me change my color again. So we're gonna find the slope over here, man. But see, the way they're saying it is okay, man. We can use it. We can use what we found. We can use what we found here. See, or you can just solve it from the beginning. See, it doesn't really matter. You can use what you found, but you gotta know what is what. Okay. You know what? Let's do it. Since we already solved the thing, let's do it a smart way. Let's compare each equation. The first equation is a. They give you 2x plus 3y equals to 18, right? Okay, so the equation was solved. We'll solve that. See that? We'll solve that. You started with it right here. So we'll put it here. Ax plus by is equals to c. And notice what is going on. Notice that a is equals to 2, b is equals to 3, c equals to 18. You see that, right? Because you compare those, that's what you're gonna get. So then, since we already did the work, we did the work here. Okay, so what they want us to find, I'm reading here, they want us to find the slope for each line. Okay, fine. So slope for that particular one right here, for A is slope is equals to A is minus A over B, okay? And that is equals to minus 2, A is 2, B is 3. That's all. That's all they're saying, man. You see that, right? Just if you can't see it, think about it clearly, you will see that. Okay? You know, if you think about it clearly, you will see that. You see. So, I hope I did it right. Let me see. 2. Yes, I did it. I'm sorry. Let me see. Yeah, I did it right. The slope is minus 2 over. And then, what is B say? What is that B? Okay, B is a different equation. Okay, fine. B is that equation here. What is that thing? It's 4. Oh man, I can't see. 4x minus 2y equals to something. What is that? Minus 1. Okay, so you compare it to ax plus by equals to what is that? C. Yeah, it's getting all over my eyes, man. Right here. Okay, you see that A is 4. Here B is minus 2. Here C is minus 1. So to get the slope right there, here the slope is equals to remember we got A over B, and then B is what? A is 4, and then B is minus 2. You see that? And that's the same thing as minus 2. So the slope is minus 2 in this case. I hope you see what I'm doing, right? Yeah, the slope is minus 2. Okay. The slope is did I make a mistake? Hang on, let me check myself. Just give me a minute. Yeah, I made a mistake. See, because I forgot this sign or this sign. You gotta put that sign in here. You put that sign. It's like I just dropped off that sign. We can't do that. Let me clean this. You can't drop off that sign. It's like equals to. It's like times minus 1 times the slope minus 2, and then it becomes the slope is positive 2. You see that, right? Sorry, I dropped off that sign. See, you can't drop off that sign. You gotta use that sign, okay? The negative sign. Okay, so let's do C. This time I hope I remember. Don't drop off the sign. Did I do this? No, I didn't do it over here. I did it right over here. Okay, so let's do C. What is C? 3. C is 3. Let me see. 3x minus 7y. What is that? Equals to 21. Okay. Let me make sure. Equals to 21. Yeah. All right. So you compare with our standard form. Ax plus by is equals to C. You see that you compare. If you compare, you see that A is 3, B is minus 7, C is 21. We don't even need C to get the slope. It's okay. But anyway, so the slope is equals to, you remember, it's minus A over B. Remember, that's what we'll find. Don't forget right here. Okay. And then, so we'll substitute. It's like you're multiplying that with negative 1. So let's put that first before I forget it again. Negative 1 times, what is A? A is 3. Okay, B is what? B is minus 7. Minus 7. See, this is how I forget. So I put that in there. That way I don't forget. So basically, this is 3 over 7. That's the slope. That's the slope for C. Because if you multiply negative 1 times that fraction, it will be positive sign, okay? So we're done with that. Let's go to the number 3 and 4. What is referred to slope into the form of found in 1. Okay, what is the y-intercept? Okay, I know what they're asking. I know exactly what they're asking. They want you to refer to, you remember in one, let's see right here. In one, this is number, what is this, number 3, right? This is number 3 in one. We found this right here. We already did it right here. That's what they ask. What is the y? Let's see. What is the y-intercept? The y-intercept, we wrote it down before. Y-intercept is, we wrote it down here. See right here. Y-intercept is equals to C over B. Remember, after we solve it, we got it right here. Okay, C over B. That's all. That's all that is asking. Okay, y-intercept is C over B. What is it? Yeah, that's all. Okay, so number 4. Use the, we're doing this one. Use the result of 3 to find the y-intercept for each line in 2. Jesus Christ. So they want us to go back here, find the y-intercept. You remember the y-intercept? I even wrote it down here. Sorry. I even wrote it down here. C over B, okay? That's the y-intercept. And then for each equation, you gotta do that. But you gotta read it up here. What is C? What is B? For the first one, C is 18. So you say 18 over, what is that? What is B there? For the first one, B is C 18, B is 3. Okay, for the second equation, C is minus 1, B is 2. For the third equation, let me see. C is 21, B is minus 7, okay? So you simplify all that. 3 divided 18, you get 6. 3 divided, no, there's nothing here. No, you leave it there, there's nothing to change there. This one, you get equals to minus 7 minus 3, right? So the y-intercept for each of them are there, okay? And don't forget, y-intercept is where x is equals to 0. So x is 0 right there, like that. So x is 0, like that. Here, x is 0 minus 3. You see that, right? So, yeah, I hope you see that. What did I do? Hang on a minute. What is I think I did it right. Hang on a minute. I think there's a mistake. There is a mistake in B. Let me look at B again. BC is minus 1. And then, okay, I made a mistake. Because then this is minus 2 too. See right here? It's minus 2. I read that wrong. So that's that one is actually equals to half. So it's a half. Sorry about that. It's a half right there. Okay. I think we're done with that problem, man. It's a long one. We're done with it, so we'll leave it there. All right. Here is the example number 11. It's about colleges again. He says the table lists the average annual cost Y in dollars of tuition and fees at a two-year colleges for selected years X, where year 1 represent 2012, year 2 represent 2013, and so on. Okay, then they hear the problem. See what they're doing now. They represent. You can let anything represent anything. Year 1, right? X are in years, right? Year 1 represent 2012. Year 2, 2013. Year 14, 20. I'm sorry. Year 3, 2014. Year 4, 2015. Year 5, 2016. And then the costs are given there. So X represent years, Y represent cost. Okay, so what they're saying, they are write 5 ordered pairs X, Y for the data. Okay, write 5 of them. We'll have to conserve space because this one will take a lot of space. So I will try to conserve space by writing small. Okay, so number A. Let me see how many. We'll have 4. You know what? Well, let's keep going. I might have to divide the page into 2. That way I can convert space. Let's say 1, 2, 1, 2. Let's divide that. Let's go like that. We'll just divide the page into 2. That way we'll make sure we'll have enough space. We're gonna draw. I think we're gonna draw a graph on this problem. So that's gonna be a problem for me. Okay. It's gonna be a problem because we don't have a lot of space. Okay, so it's a write 5 other pair for the data. That's it. That's number A. 5 other pair is you just these are the other pair. 5 of them. You keep Y. X is the. I'm sorry. X is the year, and the cost is Y. So this is X and cost. Let me see. Yeah. Yeah, year represent X. Okay. So that means we're gonna have to write these 5 of them. 3. The cost is 310. The second one, X is 2. Are you sure I'm doing it right? Just give me a minute. Yeah, I think he said that's what they want. So that's what they want. That's what I have to do. That's kind of. I don't know why we don't put the date, the year. Okay, it's fine, because they actually represent the year, but with numbers. Okay, so when we get to statistics, we're gonna explain why, that kind of stuff in more detail. Okay, 2 is 3,340. Okay, and then the next order pair is 3, and then you have 3370, and the next one is what? 4. You have 3460, and the next one is 5. You have 3520. Those are the other pair they want for the first one. Okay, and then for A. For B, plot the other pair as well. Do the points line approximately in a straight line. Okay, see, this is what I'm afraid of, man. We don't got enough space. Oh my God. And then they're in 3,000. The Y values are in 3,000. I'm gonna have to squeeze it, man. I'm gonna have to squeeze that in. Okay, let's do B. I'm gonna have to squeeze it. Let me see. Y is in 3,000. You know what we can do? Sometimes when you use a longer interval unit, you can see the graph well. But this time I don't have space, so I have to squeeze it. We really have to. So we got 1, 2, 3, 4, 5. We got 5. We got 5 values. Let's do it like that. We're doing this is X, this is Y. Okay. Alright, this is 0 here, right here is 0. Okay. So see, the unit is gonna give us problems. So for X is easy. We got 5 things in X. Oh my God. So let's do 1, 2, no. We'll do 1. We'll do it like this. 1, 2, 3, 4, 5. We'll just squeeze it in like that. Okay. You know what we can do? Oh my God. So we're gonna have to make it large, man, because we don't have space. We're gonna live from here to here represent like, see, the smallest one is 3310. The next one 3340, 3370, 3460, 35. So let's do it like this. Oh my God. Let's do it. Oh Lord. It's gonna be hard, man. Let's do it. let's do it 3 3 3 3 see 3300. Okay, so 2 spaces. You see this space here, 2 of them represent 3300. So we'll go to the next space. We'll jump 2 is here, 2 is here, 2 is here. We got 1 2 3 4 5. We got 5 of them. 1 2 3 4, and then the next 2 is here. Okay, so we'll say since the last one, the biggest one is 3520, and we started from 3 3. So this has to be somewhere. It has to be like 30. It gotta be somehow 3600. Okay, that way we can accommodate that. This is gonna be hard to draw, man. It's really gonna be hard to draw. So if that's the case, from here to here, how many units do we want it to represent? We want it to represent what, 1000? If that's 1000, then that's that's too much. Let's really represent let's see, 33 10, 33 40, 33 70, 3 4. Okay, so let's start from the top. From here to here, oh man, from here to here, let's this be 3. If this is 3 5, right? 3500. So the space will be 100, right? So if we would do, so if each space is 100, this will be 3 like that, and this will be 3 5 like that. I don't know if that makes sense. Yeah, I think well, and if each space, if those 2 units are 100, then this will be 36 right here, right? 33, then 100, 34, 35, 36. Yeah, so we don't need the last one. We don't need that one. Yeah, this is hard because we don't have space. If we have space, we'll make a, you can easily see the diagram, so we'll use the space we'll have, man. So what is the first point? The first point is 1 here, and then 3310. 3310, since each from here to here is 100, so it should be 3310. It should be over here. Let me see. Maybe somewhere over here. Okay. Alright. The second point is 3340. And this 2. 3340 will be somewhere over here. Okay. And then the third point right there is 3370. So we'll start here. 3370 will be probably somewhere over here. Somewhere over here, because it's more than that. Things are over half, because half of that is 50. Okay. Okay. So the next one is 34 something. 3460 should be from 4 here, go up. 3460 should be, because that's 50, it should be somewhere here. Actually, let me see. This one can go up a little bit. That one can go up a little bit right here. This one is closer. Let's get it away from the line, somewhere here. Okay. And then the 51 is 3520. 3520 should be, let me see. 3520 should be somewhere, maybe somewhere here. I don't know, man. So did they say, did they format? What is the first one I drew? 3310. Actually, I made a mistake there. It shouldn't be all the way. 3310 should be maybe somewhere here. Okay. So you see, it's kind of a line, so that's the best I can do, man. It's a positive slope. So do the points lie approximately in a straight line? Yes. Yes, it's a straight line. Yes, straight line. Because you see, we don't have enough space. It's a straight line, okay? Alright. We're just doing an approximation. C. Use the other pairs, this and that, to write an equation of line that approximates the data. That equation. Give the final equation in slope. Okay. So you use those 2 points. That's C. Okay, I think we might have enough space. See, they say use this point 2, 3, 3, 4, 0, and let me see, 4, 3, 4, 6, 0 to write equation of a line that approximates the data. Okay, that's what they want. That's C. Okay, to write the equation of a line that approximates the data. So, well, we'll have to find the slope. Once we get the slope, then we can, what else did you say? Give the final equation in slope intercept form. Okay, so once we find the slope, then we use any one of those points and find the equation, right? So it's actually not difficult. You get the slope first. Remember, we did this before. Get the slope. Let's use let's say this is initial and this is final, okay? Alright, final. That's a way up, I remember, don't make mistake. So the slope will be, is changing y, rise over run, okay? Changing y over changing x, that would be 3, 4, 6, 0 minus 3, 3, 4, 0 over 4 minus 2. So you do that, what do you get there? You do that 3, 4. So if you do that, I know that hang on a minute. Okay, you do that, you get 120 over 2, which is 60, okay? That's what you're gonna get. Alright, that's what you're gonna get as the slope. And then we use the slope and 1 point, and then what did he say? Slope intercept form. Slope intercept form. Do you remember we want to form an equation like this? Slope intercept form is like this. Because this is y intercept, that's slope. So we want to form an equation like that. So we got slope 60. We got slope 60. So what is y-intercept? How do you determine y-intercept, okay? You know what? So we got the slope. You know what we'll do? Let's do, since we don't have the b-intercept, right? Let's use the, what I call the point slope form. So we use one variable and we express it like this. I mean, we use one of those points, one of those ordered pairs. Let's use the first one. Let's use this one, and then remember this equation y. Let me see, what was that again? Y minus y1 is equals to slope times x minus x1. Remember that we did it a lot because that's the only way we can do it. Then when we'll simplify, we'll put it in the slope intercept form. That's what they said. Let me see. Give the equation. Okay, that's what they said. But it's okay. We can put it in that form after we'll solve, because we have no choice. We have to use 1 point. So we use that point there. We have y minus the y value is that one, 33, 40. Okay, it's equals to, what is the slope? 60. X minus, what is x1? 2. Okay, see? So we'll simplify this. We'll have, that's the same thing as 60x minus 120. Okay, so that's y is minus 3, 3, 4. Okay, okay. So we keep going. We have to have y the left side. So we say y is equals to 60x minus 120 plus 334. Oh, you see that when we move that over, it becomes a positive sign. So that's, we'll simplify the right side, we'll get 60x minus, it's gonna be plus. So we'll subtract 120 from that. You get 3 to 20, like that. I think so. That's what you get. You know. But anyway, so this is the slope intercept form. It's in the slope intercept form now. The slope is 60, intersect is right there. So what do they want? So we did that. Use the equation from part C to estimate the average annual cost at 2-year colleges in 20 cents to the nearest dollar. Hint, what is the value of X for 2017? Okay, let me make sure I understand that. Use the equation to estimate the average annual cost at 2-year colleges in 20 cents to the nearest. Okay. See, 2017. Look. Oh, 2017 is not even given. So it's each year is represented by 1, then 2, then 3, then 4, then 5. Okay, so 2017 will be 6. So what do they want? Use the equation. The annual cost. Okay, don't forget the y is the cost. Y is the cost. So basically, what they're saying is when x equals to x, when x equals to 6, then what is the cost, right? The cost, because y is the cost, it will be 60 times 6 plus 3220. What is that? Man, I guess we did the problem. That's D, right? Let me see. Yeah, that's D. So we did all the problem, man. That's what they're saying there. That's D right here. Sorry. That's D here. DC, when x is equals to 6, what is the value of y? Y is equals to that 6 times 60. What do you get? 6 times 60. Okay, you get 360 plus 3220. You add that, what do you get? You get, that would be 3580. Okay, so that's what I got, my estimate, man. So okay, I think it's right. So the cost in 2017, based on what we did, the cost would be this 3,580, and I think we did it. So, but anyway, that's it. We'll move on to the next thing. Okay, here is the next problem. It's about Twitter. It says the table gives the worldwide number Y of monthly active Twitter users in millions for selected years, where X equals to 1 represents 2014, X equals to 2 represents 2015, and so on. Then we're supposed to solve all this problem. So basically, we've seen that before. The first year, 2014, is represented by X equals to 1. Alright, the rest of the years, keep representing like that. And then the users are here. So the year is the X value, representing by 1, 2, 3, and then the Y value is the monthly users right here. The number of monthly users in millions. Okay, it's in millions. Okay, so what do they want? Write 4 ordered pairs. Okay, those are the ordered pairs they give. So that one is easy. Again, we'll conserve space because I think in B they're gonna have us plot a diagram. So let's conserve space. A is an ordered pair. They want us to write that. Remember, X is 1. Okay. X is 1, 2, 3, 4, 5, okay? 1, 2, 3, 4, no 5. 1 and 2, 7, and 1 million, okay? That is 4, okay, 4 ordered pair, okay, fine. 2, And what is that? 304. Okay. And then 3 is 313, and then 4 is 326. Okay, it's not changing much. All right. So those are the others. It says plot the other pairs. Do the points lie approximating a straight line? Okay. They want us to plot the other pairs. Okay. So we're gonna do the same thing. That's B. We're gonna do the same thing we did in the previous problem. Let's plot it. There are 4 points, and 1, 2, 3, 4. X 1, 2, 3, 4, and then Y starts from 270. So this one is not that bad. So let's do it. Let's do it. Oh, sorry. What the hell? I did something wrong. Just give me a minute. Let me get it up there. Hit that again. Okay. Alright, so B, we're gonna plot this like that. Plot that like that. Okay, so we don't really need this 4 of them. Well, we can come all the way down here like that. This is X, this is Y. Okay. X is 1, 2, 3, 4. Let's do it. 2 spaces represent 1, 2 spaces 2, 2 more spaces 3. Let's move that X here. Okay, so we get 2 more spaces. This is X. Actually, I don't want to go too far. Let's be careful, because I might have to use that space for more. This is X. 2 more spaces over here is 4. Okay, this is 4. All right. And then for Y, what we need to do, let's say here, this is 0 here, okay? Let's say there is, we'll do 300, okay? 1, 2, 3, 4, 5. Okay, so here we do 1, 2, 3, 4, 5. You gotta be careful. You gotta use, make sure you know what? Actually, no. Let's make it a little nicer. Let's clean that. We'll make it a little nicer. Because we got plenty of space. It's not. Let's do here 300. Okay. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So each unit is 30. Because there are 10 of them. So because we end at 326. So over here, 1, 2, 3. Over here would be 390, okay? Because each unit is 30, okay? Now, this is good. So let's plot the point. You have 1 goes with 270. Remember, each unit is 30. Each unit is 30. So we got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be over here. 270 something will be over here. Let's clear. You don't need that one, okay? So we'll plot that one. Then 2 is a 304. Each unit is 30. Let me see. Actually, yes, okay. 2 is 304. 304 should be somewhere there, And then 3 and 313 should be somewhere there. Somewhere quite there. Let's make it over here. Okay. And then 4 is 326. 326 should be, let me see, 30, probably somewhere here. So our line should go like I quite didn't do it right. It should be approximately like that. It's a line. So Is it here? It's a straight line. Yes. Yes. Straight line. Because we may need that space to solve problem. Then what is the action? C. Use the ordered pairs this and that to write an equation of a line that approximates the data. Give the final equation in slope-intercept form. Okay, here are the points given, right? Let me see. 1, 2, 7, 1, 3, 3, 1, 13. Okay, I'll say this is initial, this is final. And then remember slope. We have to find slope first before we can form the equation, okay? Slope m is equals to rise over run, okay? Alright, so that's the final point and the initial point is there. So we'll do 3, 1, 3, that's for rise. 2, 7, 1 over, what is that? 3 minus 1. So what is that? You know, if you do that, you work that out, you get 42 over 2, okay? And then that will give you 21. Okay. Alright, so that gives you slope is 21. M slope is 21. So once you get there, you can use any point. We can use the first point or we can use the second. We use the first point to find it. We're using this, remember what they call that point slope form. Minus 1 is equals to slope times x minus x1, okay? So we use that. Y minus 271 is equals to slope is 21. X minus x1 is what? 1. Okay, we clear that out. We'll get 21x. Okay, 21x. 21x minus 21. Okay, that's y minus 271. We say y is equal. So we'll move 271 the other side. It becomes positive. We got 21x minus 21 plus 271. Okay. So we'll simplify that. We got 21x. So you get that. That's actually we're done. We're done with that. See slope intercept form. So the slope is 21, as we found it. The intercept, y-intercept is 250. Okay. All right. So once we got that, what do they want? Use that to find. Give it in. So we did that. Use the equation from PASI to estimate the worldwide number of monthly active Twitter users in 2018. 2018 wasn't given us, so we can say 2018 gotta be 5 if we follow the pattern, okay? Okay, so 2018 x is 5. Let's do it. Actually, we can do it here. In 2018, okay, sorry. Oh, Lord. 2018, and then y will be, we're going to estimate the user. Y, remember, y represent the users. Let me see. Let's go to the original. Yeah, y represent number of Twitter users, okay? So to find the users, we'll say y equals to 21 times 5 plus 250, okay? So we'll multiply things up and 10, 105, okay? 105 plus 250. What do you get? What do you get there is, what is that one? It's 355. So the users that year is 355, 2018. Actually, you know it's in millions, right? 355, it's in millions. 355 millions, okay? 355 million users. Users of Twitter in that year 2018, and then we're done with that. Then I think we're done. Yeah, we're done with that. We'll leave it alone. All right, here is the next problem, number 13. Okay, it says the points on the graph show the annual average number Y of paid music streaming subscriptions in millions, okay, in the United States for recent years. X. Here, X is equals to 1 represent 2011, X equals to 2 represent 2012, and so on. The graph of a linear equation that models the data is also showing. Where is the graph? It's showing somewhere. I don't see it in the damn graph. Oh, I see graph. I'm sorry. I'm looking for the graph of a linear equation. Okay, the graph of the equation. I was looking for equation. So the graph is showing there. Yes. Okay, and then we're gonna do all these problems, man. We're gonna do 1, 2, and then 2 has A, B. Okay, so let's get to it. Alright, notice what as it says, use the ordered pairs shown on the graph to write an equation of the line that models the data. Give the final equation in slope intercept form. You see that language? Write an equation, right? Write an equation that models the data. Okay, so we're modeling data here. I told you linear equations are very, very useful. Okay, so let's do the first one. The first one is they want you to use the points given. See, they give you 2 points. They want you to use it to use those points to write an equation that models the data. Okay, so let's do I. Roman figure I is let me see. They give you that 1.8. You see that? Those are 2 ordered pairs, and then 5 10.8. They give you that. They say we're looking for give you an equation in intercept. I'm looking for an equation. Which is the same thing we did before. You just find slope. From the slope, let's call this initial, call this final, okay? And then we'll find the slope. Slope M is equals to what? Let me see. Rise, don't forget that, rise over run, okay? And then that's, let me see, 10.8 minus 1.8 over, what is that? 5 minus 1. So that would be, slope will be, subtract that, you get 9.0 over 4. That would be slope, okay? Yeah, 9.0 over 4. Okay, so the slope is 2.25, okay? Alright. So using the slope and 1, we can use this one, the initial point, we'll find the equation. Using the what I call slope, point slope form. Say y minus y1, alright, is equals to, let me see, equals to slope m times x minus x1. Okay, so we do that. What do we get? We get y minus 1.8 is equals to 2.25 times x minus x1. x1 is actually 1. Okay, making sure I did everything okay. So you keep going. What do you get? You multiply things out, you get y minus 1.8 is equals to 2.25 x minus 2.25, okay? You see that, right? So then you put y on by itself, you move 1.8 the other side, it changes sign. 25x minus 2.25 plus 1.8. You see that, right? Alright. So we're making progress, man. You know, we're really making progress. Okay, so you simplify this. If you simplify that, what do you get? You get 2 2.25x minus, let me see, 0.45. I hope I did it right. So that's the slope there. That's the y-intercept there. I think I did it right. Okay. Then what are they saying? What do they want? Yeah, put it in the slope. That's the slope intercept form, okay? Right there. Slope intercept form. And then what is that saying again? The second problem. Estimate the annual average number. Using the equation we'll find. Estimate the annual average number of paid music streaming subscription in the United States in 2016. They didn't give us 20. What is 2016? So the year is over here. They didn't even give us 20, but 2016 will be x equals to 6. Okay, so we'll have to use the equation, okay? That's Roman numeral 2a. It said if x is equals to, let me say, x is equals to 6, then y will be 2.25. That's what they're asking us to do. Times 6 minus 0.45. See that? So you multiply that out and then you... Okay, here is what is going on. You get 13.5 minus 0.45 and then you subtract that, you get 13.05. Okay, that's why. So that's what they're looking for. Let me see. That's not a... Estimate the annual average subscription. So that's annual average subscription 2016. This is 2016, okay? In 2016, because x equals to 6. So that's what you get there. Alright. So let's see what is the one. It says, what is that thing there? It says, how does the answer in part A compare to the actual value of 20 million subscription in 2016 to 2.6? Let me see. Yeah, I think it's close. 26 million. We got 13 million. Wait a minute. It's off, man. Yeah, it's off. You see, because they're saying the actual subscription, actual subscription, right? Actual number is what? 22. Actual number is 22.6 million. We got 13 million, okay? Yeah, I don't know. It's off, man. It's not... because if you look at the graph, 22 point... yeah... the graph, that will have to stretch the graph. Because you got to put 6 somewhere here. And then you got to stretch the graph, you know. So the what we got is actually very low. It's almost half of the rating, because you multiply that, that's about 26. So close to, you know, what we got is low. So we'll leave it there. Our figure is low here. We'll leave it like that. Yeah, we'll leave it like that. Notice that that's actually B, part B of this one here. Okay. So yeah, the number is low, but what can we do? That's what we found. But anyway, I think I'm done with this thing here. We're gonna move on to part 3. Please subscribe to my channel, like and share this video, leave comments or questions under the video, and then I will see you in the next video. Okay, thanks for coming. Bye.